look at, yeah, on the resources, on your calendar, y'all do know there's a YouTube link, right?
Yeah.
Right there. Hello, YouTube. So just make sure you look at the playlist for geometry. So your playlist will say something. So see, this is pre-P. But you all go to your playlist and it'll be geometry, probability, something like that. Okay. All right. Let's get started. So this was one on the IXL. I just want to go over this because I think it's on the third skill or the second one. No, the third one. Okay. So look up here. This is from IXL. Just look. It's not on your paper. It says you pick one card from each set and find the sum. How many different sums are possible? So here's the first set. Here's the second set. So if I do sum, what does sum mean? Total. So we add. So if I do 4 plus 2, what is that? 6. So there's 1. 4 plus 3? 7. 4 plus 4? 8. Okay, but I do have to see how you have to show a little side work. Okay, you can't be doing these and not showing work. 5 plus 2. Okay, pause. 5 plus 2 is 7. Isn't that already on here? So do I need to write it? No, because I already have 7 on there. So let's do the next one. 5 plus 3? 8. It's already on there. So I need to write it. 5 plus 4? 9. So that's another sum. Then you do 6. 6 plus 2 is already there. 6 plus 2 is already there. 6 plus 3 is already there. Is 6 plus 4 there? No, because 6 plus 4 is 10. Okay, and then the last one was 7. 7 plus 2 is there. 7 plus 3 is there. 7 plus 4 is not there. Which is what number? 11. So how many different sums is there? If you count all these. 6. So the answer would be 6. Okay, that's on your IXL. And we didn't specifically do this in class, but that's what it means. Okay? This is like basic probability. It's like 6th grade. Okay? So all it asked us was how many different sums is there? There's 6 different ones. So just don't repeat it. Okay? Alright. Let's move on for today. Okay? Can we have that paper? Green paper now. Alright, here's the essential question. The objectives. Today we're going to do probability of 2 or more independent events. And we're going to do that by analyzing. Okay? What is a compound event? What is the word compound mean? Yeah, multiple. So it's not just one thing happening, it's multiple things happening. And it's 2 or more. So today we're going to do 2 events and 3 events. Okay? Example, you roll a number cube twice, rolling a 6 on the first roll and rolling an odd on the second roll. How do I know it's compound? Because how many times did I roll it? Twice. The first event was the first roll, second event is the second roll. Okay? Alright. And then this is the compound probability rule that we're going to do today. Okay? Alright, here's our first scenario. More sundaes, but this is called a fronde. Why is it called a fronde? Because it's frozen yogurt. Yeah. Frozen yogurt. So you have options for your yogurt. That's going to be vanilla, chocolate, and strawberry and peach. So how many total? 4. Put a 4 here so you don't forget. 4 options for the yogurt. And toppings. How many options? 3. Okay. So everyone on the same page. Let's keep going. Write an organized list for the sample space that represents different fronde options consisting of 1 yogurt and 1 topping. So I know we already did tree diagram, but we're going to do another one today so you don't forget what we've already learned. So I'm going to do my tree diagram to the right. So first are the 4 toppings. So we have vanilla, for vanilla, chocolate, strawberry, and peach. Okay? It's frozen yogurt. And for each one of these, how many toppings is there? 3. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1. Okay, and the toppings are nuts, sprinkles, and granola. So NSG. So nuts, sprinkles, granola, NSG for each one. NSG. Okay, let's see if I can. There we go. Okay, please draw your tree diagram so you don't forget. This was one of the IXL skills. Okay, with sample space. Alright. So if I look at this, how many options do I have for all this? 3 for each one. So what's a quick way to figure that out? 3 times what? 4. It's 12. Yeah. So again, 4 times 3. 12 options. So this was the fundamental counting principle. We learned this last week. Okay. So this is just how many outcomes there is. We're not doing probability yet. Can I move forward? Okay. This time they changed the scenario. Okay, so it says, Peter and Avery each ordered a single flavor cone with no toppings. Write an organized list or sample space that represents the different single flavor cones that Parker and Avery could buy. So they're just choosing frozen yogurt. They're not picking any toppings. Okay. So we could show this by listing all the letters like vanilla chocolate, vanilla strawberry, vanilla shake. But we don't have time for that. Okay. Let's just calculate how many options we have. How would I do that on part B? How many options does Parker have for the first event? For yogurt? 4. Oops. Right. Parker has 4 options. How many does Avery have? 4. So how many possible possibilities do we have? 4 times 4? 16. Okay. If you want, please write the word option so that you know we're just calculating options right now, and that's all. Okay. Okay. Good. Okay. Here's a different scenario. A triple decker Froyanza. We're just gonna say triple decker. Okay. This is. Okay, this is when Luna orders a triple decker with 1 serving of chocolate, 1 serving of vanilla, and 1 serving of strawberry. So this is a cone with 3 servings. Okay, it's like a 3-scoop thing. Write an organized list for this. But again, we're not going to do the list right now. We're just going to calculate the outcome. So how many different outcomes can we have? You're on the right track, but let's think about it. This is the key word here. Order. Okay? So, she only picked how many flavors? How many flavors did she put on her cone? 3. So for the first option, she has 3 options to pick from for the first scoop, right? But we learned this the other day. The second scoop, there's no longer 3 options. Now there's how many? 2. And then for the last scoop, there should only be 1 option left. So this is when we decrease by 1. So then how many different possible stacking orders can we have? 6. No. Nobody's going to be. Or ever. I told you. We abuse, misuse, no longer use. Alright, let's go to the next page, 2.1, 2.1. Alright. So, since you've already seen the 2 different scenarios, the first one was just picking a yogurt flavor and a topping. The second option was only 3 scoops, right? Okay, consider that. Which situation represents compound events? Both of them or just one? What does compound event mean? 2 or more. So did I have 2 or more things happening for both scenarios? Yeah, so both. They both represent compound. How do I know? Because the first one was choosing yogurt and then a topping, that's 2 events, right? And then the second one was choosing your first scoop, your second scoop, and your third scoop. That was 3 events. So they're both compound, okay? Okay, good? So, next page. Describe the events that make up the compound in each order and equivalence. Okay, we already did that. Okay, when we did the first scenario, the fun day, where you choose your frozen yogurt and your topping, is that independent or dependent? Independent, yeah. Because if you choose chocolate yogurt, does it matter? Does that affect your topping? No. Okay. So that was for the fun day. Alright, now we're gonna do some actual calculation, right? Okay. Suppose you decide to build your next fun day by randomly selecting a yogurt flavor and topping. Okay? What is the probability of choosing a fun day that does not have chocolate yogurt and, circle that word, does have granola? Okay? Again, this is a compound event because how many stuff is happening? 2. First you choose your chocolate yogurt. Sorry, you don't choose chocolate. And then the second event is choosing granola. Okay? So the first event is choosing a flavor that is not chocolate. What is that probability? If I don't choose chocolate, how many options do I have? 4, right? And how many of those are not chocolate? 3 are not chocolate. So that's the first probability. So probability of event A equals 3/4. Okay, write that down. That's an A, sorry. So what does this represent? Me not choosing chocolate. Very good? Okay, let's do the second event. Event B. Choosing granola as my topping. What's that probability of B? There's 3 toppings, 1 over 3. Remember, the event is that I choose granola. So if I choose granola, that's 1 out. So I have A and B. Everybody agree? What? With the fractions? Okay. What am I going to do with those fractions? With the word and, because I need to calculate both happening. Multiply. So that was 3/4 times 1 over 3. Okay, so this is a compound. This is A, this is B. So what is that? This is why we practice this the first day. We come back for review. 3 times 1? 4 times 3? 12. Both of these divide by what number? 3, good. So 1 over... And that is all you have to learn to do today. Compound with the word and. Okay? Tomorrow, sorry, not tomorrow. Thursday, you're going to do the word or. Here's why it matters. Is it the same if your parents tell you, hey, do you want to go eat Chick-fil-A and Raising Cane's today? Or they say, do you want to eat Chick-fil-A or Raising Cane's? Is that the same thing? No. So that's why we have to do it separately. So today we did and, Thursday we're going to do or. Alright? Let's keep going. I'm going to let you try one on your own. And not hold your hand. Okay? You're doing numbers 3, part A, B, and C, just like we did together. Okay? I'm going to give you 3 minutes. Probability of choosing chocolate. 6th period. Eva, not here. Layla. Layla, could you share the probability of choosing chocolate as your flavor for event A? Yes, the probability of A? Yeah, that's correct. EA? Yes. 1 over 4. Good job, Layla. Okay, everybody write this down if you don't have it. The probability of event A is 1 over 4. Good job. Okay. Why is it 1 over 4? Because how many options is there for yogurt? 4. And what's choosing chocolate is how many? 1. Okay. Alright, event B. Event B. Listen, event B is choosing a topping that is not granola. What is that probability? Let's see. Xavion. Can you give me the probability of event B, which is not choosing granola? 2 over 3, good job. Why is it 2 over 3? Because there's 2 toppings that are not granola, right? Out of how many total? 3. Okay, good. Alright. Repeat it. So there's 2 options that are not granola, and there's 3 total options to choose for toppings. So that's why it's 2 over 3. Okay. Now these 2 events are compound. So what do I need to do with them? Multiply. So here. Yeah. Especially if you're by the front, because you're by the screen. So okay, 6th period, please write this down if you don't have it. The probability of A and B equals 1 over 4 times 2 over 3. So that's 2 over 12. What did you divide by?
2.
Good.
You get 1/6.
1 over 6 is correct. Good job.
That's use my brain how to.
Good job.
That's easy for this part.
Okay, I need to see. I'm gonna walk around and see where you're writing stuff.
Oh Lord.
You have good conversations. Yeah. All right, you can flip the page now. Okay, we're almost done. Relax, relax. Okay, listen, compare the probabilities between question 2 and 3. So number 2 was the one we did together, number 3 is the one you did on your own. What mathematical relationship exists between those 2 events? What did we do? We multiply. Do you know what you call that in math? Start with the P. No. Product. Product rule. It's just a fancy word of saying multiply. Okay. Alright. Everybody wrote that down? Okay. We're gonna skip number 5. Just skip it. Let's go to the last question. Why do you think multiplication is performed with compound probability using the word and? Starts with an F. Who remembers the principle from last week? Starts with an F from your yellow notes. What's that principle called? Oh, you're talking about dividing fractions, keep, change, flip. So that's a strategy we use to divide fractions. I'm not talking about that.
Oh my god.
It's a principle we learned last week. It's what you're doing in your Excel.
Function.
Yeah, fundamental counting principle. Okay. That is why we're multiplying. Okay, good job.